Clause 4.4 is titled Management System and Processes. The requirements are defined in detail if you look at ISO 9001. But ISO 14001 and ISO 45001 define these requirements in a more general way. The first sentence from Clause 4.4.1 of ISO 9001 states that the organization shall establish, implement, maintain, and continually improve the processes needed for the quality management system. What does it mean to establish, implement, maintain, and continually improve? It means PDCA. That stands for plan, do, check, and act. It means that the processes are required to improve gradually through the PDCA approach. A process means converting input into output, and a procedure means a set of activities in a logical sequence from input to output. This was already explained in the previous presentation. The standard asks you to determine the processes needed for the quality management system. Determine the input to the process. Determine the output from the process. Determine the sequence and interaction, maybe with other processes. Determine appropriate process performance indicators to decide whether the process is functioning well. Determine the resources required to execute the process. Determine responsibility and authority for the effectiveness of the process. Determine the risks and opportunities associated with the process. This will be explained in the presentation on Clause 6.1. Evaluate the changes, and in doing so, improve the process. Each department or function must identify the processes relevant to the management system. The standard does not specify any particular format for maintaining documentation and records for these requirements. This will now be explained with some examples. The organization can use a turtle diagram. The organization can use a SIPOC diagram. That stands for supplier, input, process, output, customer. The organization can use tabulated data to map the processes. In this table, the function is sales and marketing, and the process is inquiry handling. In the inquiry handling process, the input is a customer inquiry, and the output is an offer to the customer. To turn the input into the output, that is, to turn a customer inquiry into an offer to the customer, we need manpower, travel arrangements, computers and internet, and many other resources. At the same time, we need product stock status, current order status, product brochures, competitor data, freight rates, and many other supporting documents. In conclusion, a number of resources and supporting documents are required to convert input into output for the execution of the process. The standard also requires setting a process performance indicator to determine whether the process is working well or falling short of expectations. In this example, the process performance indicator could be the inquiry to order conversion ratio, the order booking value in terms of money, the number of orders booked, or the sales turnover value. The indicator may relate to efficiency or effectiveness. In this example, the inquiry to order conversion ratio is 35%. The value of 35 is determined based on past data. The past period could be a quarter, 6 months, or a year in order to have an appropriate base value for the data. The base value is not called the objective. There is a very fine line between the base value and the objective. In this slide, you can see the past, present, and future. My daughter has completed 1st through 9th grade in the past. My daughter is currently studying in 10th grade. My daughter will study in 11th and 12th grade in the future. If I look at her past report cards, I see that my daughter can easily and consistently achieve 80% marks. Therefore, 80% is set as the base value that my daughter can easily achieve. The actual score in 10th grade will be compared with the base value to determine how she performed in 10th grade. My daughter has a goal to get admitted to the medical field after finishing school. Getting into the medical field isn't possible with just 80% marks. She has set a goal for the future to score 95% marks in 11th and 12th grade. This is set for the future. That means it's the objective. The base value comes from past data. The objective is for the future. This is another example to help understand process mapping. The name of the function is purchase, and the name of the process is procurement. In the procurement process, the input is the purchase request, and the output is the purchase order. To turn the input into the output, that is, from purchase request to purchase order, we need manpower, computers, an internet, and SAP or ERP software. At the same time, we need material specifications, a list of approved suppliers, and technical and commercial approvals. In conclusion, a number of resources and supporting documents are required to convert input into output for the execution of the process. In this example, the process performance indicators could be the number of days to convert a PR into a PO, the number of purchase order amendment events, or the number of days with no production due to lack of raw materials. Any relevant process performance indicator can be set to determine whether the process is performing well or falling short of expectations. The baseline value can be determined from actual historical data accordingly. This is another example of understanding process mapping. The name of the function is production, and the name of the process is manufacturing. In the manufacturing process, the input is raw material, and the output is finished goods. But raw material is a physical input, and finished goods are a physical output. The management system requires input and output as documentary evidence. In the manufacturing process, the input is the production plan, and the output is the production log that records the data. To convert input into output in the manufacturing process, we need manpower, infrastructure facilities, utilities like air, water, and energy, raw materials, and monitoring and measurement resources. At the same time, we need the quality control plan, the quality control report for raw materials, procedures, and safety guidelines that include do's and don'ts. In conclusion, a number of resources and supporting documents are required to convert input into output for carrying out the process. In this example, the process performance indicator could be the number of first-time pass events or the number of plan versus actual production events. Any relevant process indicator can be set to measure performance. The baseline value can be determined from actual past data accordingly. To better understand specific performance or relevant performance indicators, let's look at an example. I have a car. In January, I traveled 1,000 kilometers. In February, I traveled 5,000 kilometers. In January, the car consumed 100 liters of fuel. In February, the car consumed 500 liters of fuel. Does that mean the car's performance was good in January and the car's performance was good in February based on fuel consumption? The consumption depends on the distance traveled, which is the output achieved. It is relevant or specific to kilometers. Therefore, in kilometers per liter, the indicator is the same in both months. When setting environmental performance indicators, we need to consider the output as relevant or specific. These are some examples of environmental performance indicators. Specific effluent generation in liters per unit of product. Specific waste generation in kilograms per unit of product. Specific steam consumption in kilograms per unit of product. Specific electricity consumption in kilowatts per unit of product. The safety performance indicator is also calculated in a similar way. For example, in Factory A, there were 4 accidents that occurred last year. In Factory B, there were 40 accidents that occurred last year. Does it mean that because Factory A has fewer accidents, it is better in terms of safety performance, and because Factory B has more accidents, it is worse in terms of safety performance? Both Factory A and Factory B have the same safety performance when you look at the accident frequency rate. Both factories operate on 3 shifts. Each shift in both factories is 8 hours long. Both factories operate 365 days a year. However, Factory A has 200 employees, while factory B has 2,000 employees. Therefore, the accident frequency rate is the same according to the formula below. The accident frequency rate is an indicator of how many accidents occur per number of working hours.